Hey everybody, welcome to the video. In this video, we are gonna talk about RFC 42 consistent hashing in Apache Hudi. In 0.13 version of Apache Hudi, they have announced something called consistent hashing. So let's take a look at this RFC 42 with a small example. So I'm gonna share my screen. All right, consistent hashing. So the first question would be, naturally, what is consistent hashing, right? Consistent hashing is a distributed hashing scheme that operates independently of the number of servers or objects in a distributed hash table by assigning them a position on an abstract circle or a hash ring. This allows servers and objects to scale without affecting the overall system. Now, this concept was applied to bucket index, right? So for example, the bucket index gives you 3x performance compared to Bloom filter index. And why? Because it basically skips the part of index lookup. Now, one of the problem with the bucket index is you have to set up a static number of buckets. And as time goes, there could be a data skew problem, right? So that's when the community said, you know what, we could resolve this using consistent hashing, right? So let's read it. Hudi supports Upsert operation. Hudi supports Upsert operation to deduplicate records in a table, which depends on indexing schemes to perform record location lookup. Amongst many index option, bucket index RFC 29 achieves promising Upsert performance around 3x improvement on throughput compared to using Bloom filters. However, it requires pre-configure of a fixed number of buckets that cannot be changed afterwards. This problem could be solved by consistent hashing. It achieves the bucket resizing by splitting or merging several local buckets, only large file groups, while leaving the most buckets untouched. This feature allows us to adjust the bucket number dynamically in the background, in the background service with minimal impact on the downstream system relying on Hudi. For example, concurrent readers and writers are not blocked during the resizing operation. So now basically you can dynamically resize the number of buckets, right? This is really amazing what they have done. I wanna, before going over the demo, I wanna cover to the proposer for this RFC at HUBERTY Lee, then HUJICALRIN, Stream 2000, and YUWEIXIAO. These are the GitHub users. Thank you for your proposal. All right, let's take a look at the demo. So first, I'm gonna define the imports. Again, pretty straightforward over here, right? And again, I have a nice, sort of a GIF which shows you consistent hashing, right? So you can see the servers have been added, and then whenever an object is added, it's basically routed to the appropriate, server. So the concept is similar, is what I wanted to say. So first, we're going to define all the imports over here, right? We're going to create a Spark session. I'm using Hudi 0.13, as you can see. Here I have also defined my Spark session. As you can see, I'm using Spark 3.3.1. I'm working on locally. This is a class that's going to generate some fake data. Again, this data is used for teaching purposes. Excuse me. Ooh, sorry about that. So here basically are the settings that I have defined. So the table name and the database name, the record key. I'm using a composite key that is a combination of employee ID and the state. Precom key is used for dedupe purposes during an incoming batch of records, right? Method is Upsert, table type is merge on read. Currently, this RFC is only supported on merge on read, okay? Just wanted to make sure you guys know about that. So let's take a look at the settings. Again, these are the default settings over here. So basically when you're using it, you have to disable Hudi metadata enable. So you have to set that to false, and Hudi data source write row writer enable, set that to false as well. Now this is the fun part, okay? So Hudi index type as bucket, Hudi index bucket engine as consistent hashing. You can define your maximum bucket, you can define your minimum buckets, okay? again, these are the split threshold based on which, the bucket, the resizing would happen, right? And then basically here is the clustering. Again, I have defined that, and here is the cleaning. Basically, it's gonna keep only the latest file version, right? And these settings are given on the Hudi 0.13 release note. So I have copied these settings from the release note. So we have defined that, and now I'm basically performing an upsert. Let me remove that. Again, you can you can change the number here: 100, 1,000, 10,000, a lakh, 10 lakh, a million, whatever you want, right? You can change that, and this is going to perform that upsert basically on the Hudi data lake. So now let's execute that, and hopefully you can see it works fine. And if I go to my C drive, if I go to temp, let's go, and there you go. So here you can see I have four partition: 2020, 2021, 2022, 2023. Here is the Hudi metadata. Here you can see bucket index, right? Consistent hashing metadata. So you can verify that, right? So for the partition 2023, here you can see, you can basically see, right? So number of buckets is 256, and again the sequence number, right? So basically what's going to happen is, I'm inserting data, and based on the threshold, it will basically dynamically adjust the bucket size, right? That's basically what RFC 42 says. So again, these are some of the things that you wanna keep in mind. The index is supported only for Spark Engine using MOR table. Again, as I said, right? It does not work with the metadata table enabled. To scale up or shrink the number of buckets, user have to manually trigger clustering using the above config. So these are the configuration that I just told you, right? So yeah, basically that's that, and these are all the references that I have taken. So here you can see the references are on the release note. So if you come here to the release note, again consistent hashing, and again it's given over here as well, right? So you can come and read. So these are very informative articles, and again I have the link to the RFC as well. So if you want to read further, come and read the detailed guide, right? They have essentially given the abstract, the background, right? Their approaches, their test plan, everything is explained in a nice way. But if you're simply looking on how can I use it, so this video will help you, and this exercise notebook will also help you. Also, on a side note, if you really want to learn about consistent hashing, there's a nice video by Bytes Go. He explains the consistent hashing in a very nice way. So I recommend you to watch this video. It's a really fantastic video. So that's it for the video. I hope you have enjoyed it, and I'll leave the exercise notebook in the description. So if you have any questions, let me know your questions. And if you find any issues or any suggestions or improvements, please make sure to join our Slack, and also you can open up GitHub issues, and the community will try its best to basically help you out. Okay, that's it for the video. I hope you have enjoyed, and I'm gonna see you in the next video.